Hi, I'm Garrett Clark, and this is a Rubik's Cube. It's not an ordinary Rubik's Cube, it's called a 2x2 Rubik's Cube because there's a 2x2 array. The Rubik's Cube can become scrambled. When it becomes scrambled, it'll look something like this, All the pieces are in different spots than they should be. Our goal is to solve all 6 faces. When it's solved, it should look something like this, where all the different sides are solved. I'm here to test whether studying the Rubik's Cube before you try to solve it increases the speed in which you solve it. In this experiment, I will solve the cube 20 times. For the first 10, I am not allowed to look at the cube before I solve it, and the timer will start when I look at the cube. For the last 10, I will be allowed 30 seconds to study the cube. So let's give that cube a whirl! Solve number 1. No look. Ready, go. Alright, solve number 1. Ready, go. Done. Solve number 8. Ready, go. Done. Oh my god. Oh, hey. Wow. Very fast one right there. Okay. Done. Alright, last one, guys. We're done. Now that the easy part is over, solving the cube, here comes the hard part, the statistics. Because our sample size is low, and we don't know the population standard deviation, it's appropriate to use a t-test for this experiment. Our null hypothesis for this experiment is that there is no difference between studying and not studying the Rubik's Cube before you solve it. Our alternative hypothesis is that there is a difference between the two. And because we don't know whether it's higher or lower, it's going to be a two-tailed test. We start by finding the means for each of the experiments along with their appropriate standard deviations. The mean for the first 10 solves was 23.1, while the standard deviation was 4.59. For the second 10, the mean was 14.88, while the standard deviation was 5.85. To find the average difference, all we have to do is subtract the two means. By subtracting the two means, we get an average of 8.22. For our pooled standard deviation, we get a total of 7.44. This allows us to calculate our t-statistic, which we'll use to find our p-value. Our t-statistic ended up being 3.49. Using this value, we are able to determine what the p-value is. And the p-value for this experiment ended up being 0.0068, which means at a 0.05 significance level, this experiment is significant, and we should reject the null hypothesis. Isn't that great? The experiment worked! Now I did my experiment with a 2x2 Rubik's Cube. The results may be different for a 3x3. Maybe when you get the higher order cubes, there is no difference. Who knows? Maybe you should try this. Maybe this result is only tailored to me and doesn't apply to other people. Who knows? You should try this experiment yourself. I encourage you to, because repetition is the key to statistical significance. And with that I say, ta-ta for now! Thank you for watching.